3.2, day 1 notes, logarithmic functions and their graphs. All right, so what are logarithmic equations? They are inverses of exponential functions. And I know it's been a minute since y'all have done inverses. Inverses, the inputs and the outputs change from each other. So whatever the domain and range was for an exponential function becomes the opposite for a logarithmic. So the range on an exponential is the domain for a logarithmic and vice versa. So a couple of component information pieces about logs. Y'all, the subscript is the base. I think we might remember that. The y value, this y value, that's called an argument, but you don't have to know that it's called an argument. But what you do need to know is this is never negative. It's never negative. If I put a negative number there, I am just trying to trick you. That's all I'm doing. I'm just trying to trick you. Now the exponent is what the log equals, and guys, exponents can be positive and negative. So positive and negative is okay for the answer to a log, because logs always equal exponents, but this y value is never ever negative. All right, so here's what we're going to do. We're going to convert a little bit, we're going to evaluate a little bit, we're going to graph a little bit, and then you're going to be done. All right, so on this first part, we're going to rewrite this stuff in exponential form. So the subscript is the base, so we're going to write 6. And remember, logs always equal exponents. So this is going to be 6 to the power of 2, and the argument is the answer. So 6 squared is 36. This is going to be 289 to whatever the log equals. It equals 1/2. So this is going to equal 17. Now for this next one, the base is not written, so I know it's a common log. Y'all, logs were invented, it wasn't really, I guess it was invented. Logs were invented because of scientific notation. And remember scientific notation from 8th grade, it was like 10 to the power of whatever. This is understood to be a common log because it has a base of 10. So when the log base isn't written, it's understood to be 10. So this is going to be 10 to the v equals 5/16. That's a common log. Number 4, ooh, the words changed. So this is a natural log that deals with the natural number, the letter e. So the letter e is going to be the base on this. So this is going to be e to the x equals 4. Pretty easy. All right, now let's go the other way. Let's write this stuff in log form. So for number 5, we're going to start out by writing the word log, and then you're going to drop that 64 as a subscript. Now remember, logs always equal exponents, so the 8 has to go here because on the other side has to be the exponent, the other side of the equal sign. All right, let's practice number 6. So this is going to be log base 12 of 144 equals 2. And then on number 7 is common log. Y'all don't write base 10. That looks silly. When it's a base 10, we don't write it. So this is just simply log v equals -14. Equaling a negative is just fine. Oh, here's your natural log. So we're not even writing the word log. We're writing ln. ln of 1 equals 0. All right. So now that we've practiced converting a little bit, let's practice writing them. So we're going to evaluate these, and there's 2 things to make this so easy. Number 1, hint number 1, always make them equal x. Like this, equals x, equals x. All 6 of these, I'm going to write equals x. Remember, logs equal exponents. All right, hint number 2, write as the same base. So let me show you what I'm talking about. Let's look at problem number 9. So for problem number 9, we're going to have 6 to the x equals 216. And guys, y'all don't get to use a calculator on your test, but you should be all right finding 216. You already know what 6 squared is. 6 squared is 36. Let's multiply by another 6 and see if we get 216. And we do. So 216 is 6 to the 3rd. Y'all, when you write them in the same base, the bases just go away. It doesn't even matter. You're just going to write x equals 3. That's it. Let's take a look at problem number 10. So problem 10 is going to be 343x equals 7. All right, so again, let's start with 49 because we all know 49 is 7 squared. So if I do 49 times another 7, let's see if we get 343. And we do. So we know 343 is 7 cubed. So let me rewrite this as 7 to the 3x equals 7. It's understood to have a power of 1. Are there any questions on how I went from 343x to 7 to the 3x? Any questions on that? All right, bases are gone. Let's write 3x equals 1. Solve for x. So, of course, x is going to equal 1/3. All right, let's do it again. So 3 to the x equals 1/243. All right, y'all, let's see how high you know your 3. So what's 3 squared? What's 3 to the 3rd? 27. Do you know 3 to the 4th? It's 81. It's 81. Y'all should kind of make it easy and commit that to memory. 3 to the 4th is 81. Y'all memorize that. Your young brains can handle that. So look, let's do 81 times another 3. Then we'll have 3 to the 5th. So 81 times 3 is 243. So we're right there. 243 is 3 to the 5th. So let's write it like that. So we're going to write 3 to the x equals 1/3 to the 5th. And y'all, those are not the same bases. This is a 3, and that's 1/3. So you're going to have to take this and move it to the other side of the fraction bar. So it's going to look like this. 3 to the x equals 3 to the -5. And there you go. X equals -5. All right, let's look at this bottom part right here. Ooh, natural log. We're going to have a base of e. So e to the x equals 1. Y'all, anything to what power is 1? Yeah, so x is 0 here. All right, this is going to be 49 to the x equals 7. Y'all know 49 is 7 squared. So 7 to the 2x equals 7 to the 1st power. Drop the base. So x is just going to equal 1/2. All right, let's do this one. 6 to the x equals negative 36. What is that? No solution. No solution. All right, y'all, let's graph a little bit. All right, so when we graph, just like when we did this evaluating, we put it in exponential form, same thing. We don't really graph logs, we graph them as exponentials. Let's put this back in exponential form. Remember, logs equal exponents. So this is going to be 3 to the y equals x. Now remember, they're inverses. We're kind of going to do it the same way. I'm still going to draw a t-chart. We're still going to plug in input values of -2, -1, 0, 1, 2, but it's an inverse, so my inputs go over here. So for logs, your -2, -1, 0, 1, 2 always go in the y column. All right, so we're going to have 3 to the -2. You can't do that. You got to put that under a fraction bar. So 3 to the -2 is 1/9. 3 to the -1 is 1/3. 3 to the 0, 3 to the 1st, and 3 squared. And guys, there's not any transformations or anything, so we're just going to plot from the origin. So these fractions, y'all just do the best you can. All right, so logs are sideways. They look like exponents tilted on their sides. And that's exactly what an inverse is. It's a graph tilted on its sides, so that makes sense. You do, for sure, have an asymptote. It's going to be right here. So your asymptotes are vertical now. At x equals 0. All right, let's try that again. Let's do the natural log. So this is going to be similar to the stuff from yesterday. All right, so we're going to have e to the y equals x. T-chart over here. Now, if you remember from yesterday, I didn't go -2. I started with -1 and then did 0, 1, 2 because -2 is such a small amount. It's not even worth it. All right. If you remember, e to the -1, that was a decimal. Who has that still memorized?
0.368.
Very good, guys. I saw that. All right, so remember e to the 0 is 1. And then 2.7 is e to the 1st rounded. 7.4 is e squared rounded. Let's plot those. No transformations, so we're starting from the origin. So there it is. And again, you do have that asymptote right there on y equals 0. No, that's x equals 0. I'm sorry, guys. It's x equals 0. Shame on me. All right, so look, domain and range. Guys, if you notice, these are not like yesterday's. Yesterday started with f of x. Today they start with y's. because they don't have a domain of odd numbers. Remember, the domain and range has switched. So the domain is going to be 0 to infinity. And now your range can be anything, even 0, anything at all. And the asymptotes for these were x equals 0. But guys, will you also write the generic form? It's going to be x equals h once they start doing transformations. Let's talk about end behavior. X is not approaching negative infinity, but it is approaching 0. And you can't write f of x on this because it's not a function. So we're going to actually, it's just an equation. Y is going to be approaching negative infinity. And as x approaches positive infinity, y'all, y is going to do the same thing. It's going to approach positive infinity. All right, so in order to graph this stuff that has transformations, it's just like yesterday, y'all. We're going to find HK and plot that. So for number 17, HK is 3, 5. I'm sorry, it's 3, negative 5. It's 3, negative 5. Let's plot 3, negative 5. And once you draw this little cross, remember I draw a cross to indicate the new starting point. Guys, just extend this vertical line because that's asymptote. So you're going to have an asymptote right there at x equals 3. X equals 3. And then make a t-chart. Y'all, I'm going to do it down here because I don't have a lot of room. I'm starting to run out of space. -2, -1, 0, 1, 2. But don't forget it goes on the y side. So -2, -1, 0, 1, 2. And y'all, all we care about is the base. So we're just going to be dealing with 6. 6 to the -2 is 1 over 36. 6 to the -1 is 1/6. Go ahead and fill in the rest of these values. All right, so there's those ordered pairs that we're graphing. Just do the best you can with the fractions, but don't forget, this is our new starting point right here. We're not going to be able to fit all of them, but fit what you can. And there's your log. Any questions on 17? All right, let's do one more, y'all. Let's look at problem 19. So for problem 19, we're going to have HK at -1, -4. Go ahead and plot -1, -4. Extend out that vertical line. Make your t-chart. Put your inputs under the Y column. And then plot away, friends. Y'all, by the way, 1/3 to the -2 is 9. Let me know if you need help on understanding that. These negative exponents are tricky. So that's going to be the answer for 19.